Okay, so I have here a new example. Now we have the integration of x squared plus 5x plus 2 dx over x minus 1 times x squared plus 1. So we can write this proper fraction into a partial fraction. So we have to decompose this fraction so that we can perform integration to this. X squared plus 5x plus 2 over we have x plus 1 times x squared plus 1. No? So we can rewrite this into a partial fraction. We have first a is x plus 1 plus. And take note, we have only one exponent, no? So you have x plus 1 raised at the first degree. Then we also have the other one, we have x squared plus 1. But take note that our denominator is in second order. So our numerator should be in the first degree order. So how are we going to write the numerator? So we have bx plus c. Okay, so this is at the second order, then this is now on the first order. X squared plus 5x plus 2 over x plus 1 times x squared plus 1 is equal to what is the common denominator. So the common denominator is x plus 1 times x squared plus 1. Correct? So we cancel out x plus 1, then the remaining would be a x squared plus 1 plus bx plus c. Then we cancel out x squared plus 1, so the remaining would be x plus 1. So if we cross multiply, we can cancel these out. So the remaining would be x squared plus 5x plus 2 is equal to a x squared plus 1 plus bx plus c times x plus 1. So after this, you assigned value of x. But in this case, what would be the best value of x so that we can compute for a, b, and c? Ano kaya? So we can set x equals 2, let's say that is negative 1. Okay? So we have negative 1 squared plus 5 times negative 1 plus 2 is equal to a times negative 1 squared plus 1 plus b times negative 1 plus c, then times negative 1 plus 1. So the remaining would be 1 minus 5 plus 2, correct? That is a, since negative 1 squared is 1, 1 plus 1, therefore it is 2a, plus we have, since we have negative 1 plus 1 is equal to 0, correct? So multiply b plus c times 0, that would give us 0. So therefore a is equal to 1. After this, we have compute b and c. Set x is equal to 0, so that means 0 squared plus 5 times 0 plus 2 is equal to a times 1 plus, since we have b times 0, that's 0, so the remaining would be c, only c, then times 0 plus 1, that is 1. That would give us 2 is equal to a plus c. However, we have a is equal to negative 1. We have already computed the value of a, right? So let's use that value to find for c. So that means 2 is equal to negative 1 plus c. So therefore c is equal to 3. Now compute for b. So what would be the value of x? So let's try. Set x is equal to, let's try to use 1. Right? Let's try to use 1. That would be 1 squared plus 5 times x, that is 5, plus 2 is equal to a times we have x squared plus 1, that is 2, plus b, we have b to x, that is b times 1, that is still b, plus c times x plus 1, that is 2. Okay, so we have 5, 6, 7, 8, to this 8 is equal to 2a plus 2b plus 2c. However, we have already computed the value of a and the value of c. So we substitute in this equation. We have 8, we have 2 times negative 1 plus 2b plus 2 times 3. Okay, so b is equal to 2. So we now have all values. We have a is equal to negative 1, b is equal to 2, and c is equal to 3. Okay, so let's substitute this value in our partial fraction. X squared plus 5x plus 2 over x plus 1, x squared plus 1, that is equal to, we have this one here, that is a is negative 1 over x plus 1, plus then use again this value here, that is b, we have 2x, then we have plus 3 over x squared plus 1. Then you can finally do integration. Okay, so if we integrate this, the integration of plus 5x plus over x plus 1 times x squared plus 1, that's equal to the integration of negative dx over x plus 1 plus the integration of 2x plus 3 over x squared plus 1 dx. Negative, that is the natural logarithm of x plus 1. Okay, so take that from our logarithm of plus c. No? Then we have here, however, we cannot actually use natural logarithm or logarithmic rule to this. So we have to expand this fraction. We can actually rewrite it into 2x over x squared plus 1 dx plus the integration of 3 over x squared plus 1 dx. Di ba pwede siyang ma-separate? That is equal to negative log or natural logarithm of x plus 1 plus. Okay, so we can now use the du over u integration into this. That is, what is our u? Our u, that is x squared plus 1. Our du, that is 2x. Therefore, we can say that it is natural logarithm of x squared plus 1. Am I correct? Since this is our du, while this is our u. Then, here, what do you think is the rule that we could actually apply to this? We have the rule which is du over u squared plus a squared, the integration that is 1 over a arctangent of u over a plus c. So we have a squared here that is equal to 1. That is, therefore, our a here, that is the square root of 1, which is 1. Then we have our u squared, that is x squared. So therefore, our u is equal to x. So we can apply inverse trigonometric function. That is equivalent to 3. Since 3 is constant, you can take 3 outside of the integration. Then times, that is 1 over a we have 1 over a here, or that is where our a is equal to 1, therefore that is still 1. Arc tangent, we have u, what is our u? X, then over a, this one. Okay, so we have now x over 1, then we have plus c. Okay, so therefore the final answer of x plus 1 plus natural logarithm of x squared plus 1 plus 3 arc tangent of x plus c. Okay, so this is now your final answer for the integration of x squared plus 5x plus 2 over x plus 1, x squared plus 1. Then we have dx. For your exercises, I want you to integrate these three proper fractions.